Hi, thanks for joining me. So today I would like to talk about dumping a script for Magic Knight Rayearth 2 on the Game Gear. Now, when I conceived of this, I just thought, I've kind of crossed another threshold, sort of reached a milestone in my, my dumping of scripts. I thought I would share it with you guys, and it's turned into a couple of days, several days maybe, project of updating my dumping script here that I use, and that's actually been a really good thing. It hasn't felt good because it seemed really messy, and it's just it took me a little while to sort of get my head around the approach that I wanted to take for making some major updates to this. But I guess I'd like to talk about that whole thing if you guys want to join me for this. I mean, this might be a long video, I don't know. But I hope that it will be interesting. For starters, with Magic Knight Rayearth 2, I did a little bit of relative searching, and I figured out a general text encoding for the game. And I identified a whole bunch of offsets in the script where it looked like text was stored. So I have pairs of offsets here. There's actually quite a few of them. But this is how I do this. So I make a config file for each game that I'm going to use. So in our script file here, our config file, we're going to define some constants. These are specific to our project, so we've got the path to the project. Then the ROM itself, so that's going to be actually, it's the path to the ROM, so we include the path in it. Now we define a table. As far as I'm concerned, I mean, obviously if we're dumping a script, we have to have a table. So every project at least has a main table. So then we come up with a name for it. So anything that we dump with this is going to be called script. And yeah, I guess automatically it'll add numbers to it. But if it was menu text, I could name it menu. If I could call it whatever I wanted. And I think I mentioned this before, but most games have a text routine that prints characters to the screen one at a time, and it will either, and this is for sort of like dialogue style text, and it'll either put your diacritics, which are going to be these characters that add a different voicing to your character. So in Japanese, you've got ka, and the voiced character is ga. So you can see it's got this little mark up there. So that's what I'm talking about. That's a diacritic. And there's two types of diacritics. You've also got this little circle here. I didn't have to make that. Oops. I didn't have to make that katakana, but anyway. So like that's ho, that's po. So there's two types of diacritics. And so if those come before the voiced character, because in these old 8-bit games and stuff like that, it's just this stream of bytes. So like let's say our encoding for our Dakuten character is 08. Okay. So it's going to be 08, and then for our Ka character here, it's like, I don't know, 40. Okay, so if you wanted to represent Ga, you might represent it by 0840. Now it could be the other way around, it could be 4008. And that's really common. You can find it in either configuration. So we're setting here in Magic Knight Rayearth 2, the diacritical marks come before the unvoiced character. Okay. So that can be set to post, and also can be set to none. When you're dealing with fixed width, is what I call it, just fixed. It's not really fixed width, it's fixed length. I don't know why I called it width here. Fixed length text. So you might also have a text routine that just prints like a line, and then prints another line, and prints another line. And in that case, these diacritics will end up on a previous line. So you'll have your ka, and in order to make it ga, it basically just puts this diacritic on the line above it. Okay, and in the actual game, like the font tile is going to show this down much closer to the Ka character, so it actually looks kind of like Ga. But this is how it conceptualizes it. So if we're dealing with text like that, I do have some code in here to handle that, and so I have to define that it's fixed width. You can do that here with this. In this case, it's null because we're not doing fixed, and again, a fixed length. And you can also say how many lines above this the diacritics appear, because I've actually encountered it where effectively it's like 2 lines above it, which is weird, but I've seen that. And not for this project, but for another project, I added the ability to merge basically merge the output of this script, because before what it would, if this is not set to merge, then it dumps multiple blocks. Now, if we want to merge those, we can set this to 1, and we'll just get 1 script file, which is what we do, because there's like a gazillion different offsets here, so I didn't want to end up with a gazillion different files. So this is something that I just added now that I'm telling you about, and that is multiple tables. So I wanted to have support for some of these games that will switch their text encoding kind of on, like in the midst of its script. So you're going to be going along, and like in this case, if 40 represents Ka, at some point you're going to hit some byte like 77 here, and that switches the encoding, and all of a sudden then 40 doesn't equal Ka, it equals oo or something. So that is a thing that I've run into, and so I've gone ahead and added in a second table, and it's optional. You can make it null if there's no second table, and there isn't for MatchNet Rayearth, so that's fine. And also these switch bytes. And the reason why I added this in, and so basically, like I said, this maybe 77 is our switch byte. If you only have 1 switch byte defined here, that's going to work as a toggle. So usually when you'd hit 77, it's going to switch the text encoding. You hit 77 again, it's going to switch the text encoding back. I think I've seen some games that use 2 switch bytes, and they're different. So one will switch the encoding to a second table file, and then the other one will switch the encoding back to the first table file. So I put these in here to account for both of those situations. So that's basically all the stuff that we define in our config file, and so this is something it's going to be different, most of all this stuff for different projects. Now I also put in a pre-process function and a post-process function for blocks, which is the main stuff that we're dealing with. It's the blocks that we're going to dump out, and you can see in this case that I do a bunch of stuff in the post-processing block. Now, the reason I did this, I think, is really just to give some chance for me to do some things to the text that might be specific to the game before I pass it on to my script. And now it's a little weird because like I have this one thing that's required, so because the rest of my script, my actual dumping script, is expecting these blocks that you get back from the function that we call. They're basically strings of hex values. And so what I always do, and I basically, because the rest of my script expects it, is I split those strings into bytes. So it's basically two values. I don't know if they'd be thought of as nibbles, but I split like a long text file into pairs. So basically it's bytes, and that's convenient. That's how I've conceived of this. So the only point I'm making is I would say I could probably move this into the function that actually gives the blocks back. It seems a little weird having this required function in this pre-processing thing, but anyway. that's how I've just done it for now. And I also reset the block's numeric keys, because after you split it, I don't know, the keys aren't, they're not contiguous, numerals. So I just have this reset like array values, and that's it. And then in post-processing here, obviously, once I get this information back that it's been encoded, what this is really for is for like formatting that doesn't necessarily make sense to do in our main script. So let's see our script dumping script here. This is it. It's pretty simple. So what we're going to do is we set a max execution time. This is way high, and that's just because I was running into some trouble and I hadn't quite figured out why, so I ended up setting this really high. So we include a library of functions. We've got 4 functions in that library. We include our config file, which we just went over. So this is going to be the one for Magic Knight Rayearth 2. Now we're going to get some table files. So one of the functions in our library is get table file, and all that's going to do is just return an array based on a table file. And so I'll show you again. A table file really is just like a set of encoding, and this is our doc10. Okay, so what this is this basically is just a list of equivalencies for what is our unvoiced character and what is our voiced character. Handokten is actually much smaller. There's only one set of hiragana sort of vowel sounds that use the Handokten. We have to get those so we have access to them using the same function that I used to get the Dokten and Handokten. We're going to get our main table file, and I just added this in. We're going to get our secondary table file too, if it exists. If it doesn't, then we're just going to set it to empty, just to nothing. And so we just pass it all of those script offsets and the ROM, so that it can retrieve our blocks based on that information. Once we get it back, we pre-process it, and then we're going to pass it on to be encoded. So we're passing all this stuff basically that we've prepared, and then we're also just passing through some of the stuff from the config file. That's just so we don't have to load the configs also into the library. That just doesn't make any sense. Here we load the library, here we load the config, and then anything that encode blocks needs, we just pass to it. Then we run our post process if we need to do some formatting, and then we dump blocks, which is really saving these blocks into text files. And that's it. So that's pretty straightforward. If we go into our library, obviously these functions do a lot of the heavy lifting. Again, we got get table file. It just opens the file, splits it on commas for now. I used to have it split on line breaks, and I could still do that. I might switch it back. I was just having some trouble, and I thought maybe it was because of the formatting of the line breaks, and I'm like, I'll just do it with commas anyway. So we just make it into key value pairs, and then we return it. It's really straightforward. Get blocks. Again, like I told you, we take the script offsets in the ROM, it just reads all that information and sends it back. But the encoding here is where I just did a lot of changes. So for starters, I realized that the main problem with Magic Knight Rayearth 2 is not that it switches encoding like some games. It's really that it has mixed encoding. So originally, when I conceived of this process of encoding these blocks, I was doing it on individual bytes, 1 byte at a time, and it was all based on single bytes. So this had no handling for double byte encoding at all. And Magic Knight Rayearth has a mixed encoding. So some of it is single bytes, and some of it is multiple bytes. And I can just show you. So here we are in our Magic Knight Rayearth 2. This is like our regular table. And you can see these are all single bytes. This is a single byte, 0, 1, 0, 2, 0, 3, 1D, blah, blah, blah. But, and really I think it might, is it just our Dokten? I think it's just our Dokten and Handokten that are double bytes. It's really weird, actually. But that's how this game does it. and my dumping script didn't take that into account, and I had to rewrite the whole thing practically. Not really, but I had to do a lot of changes to it. So, so the first thing we do to handle this is I sort our table that we get. It's going to be this table that I just showed you by byte length. So, so we're going to get these double byte values. We're going to sort of be the first, values in our array, and all the single byte values are going to come after. And honestly, I looked this up on the internet. It's a user-defined key sort. So I'm sorting the keys of our table, which is just this. This is the key, and this is our value. I'm sorting that by length. We're just doing a little comparison A and B, and if it's by the string length, if you subtract A from B, it's basically like if it's a negative number, it moves it down. If it's a positive number, it moves it up, and if it's 0, it keeps it the same. Something along those lines. So so then we check to see like if the text is fixed width. We pass that in here, fixed width. And actually, this code isn't working right now, which is actually super frustrating. But I'll just have to go in and rewrite it. There's almost nothing here, you can see. So we're not dealing with fixed length text. We're dealing with text that prints out one character at a time, and basically it includes like control codes to indicate like ends of lines and things like that. So we're getting back this block of hex bytes, and so we're saying, well, this array of arrays of hex bytes. So I'm saying for each array of hex bytes, each block. So we're using this little for loop to go through each one of them. So the first one, of course, is going to be, array 0, and that's just going to be our first block, and we're going to do something, and then it's going to move on to array 1, block 1, and then block 2, and then block 3. So first we're going to get the length, and I didn't do this before, and I found out that because of how I handle stuff later on, I actually had to get the initial length, because the length is going to change. So we need to process everything for the whole length. So the length is basically just count of all the bytes that are in this block. And then I want to go through each individual byte. So again, I do a for loop. So this is while y equals 0, while y is less than the length, just keep incrementing. So I define a couple of variables here, and these are to conceptually make this easier. I mean, I can just use these values, but when I was using these values, it was a little confusing. This is only slightly less confusing, but basically we're going through each individual byte, and each byte has basically a key in the array. It's just a numerical array, so it's honestly it's just the value of y, because as we go through each individual one, we're looking at basically the byte in this block that's at position 0, and then we're looking at the byte at the block that's at position 2. It's like the 1. It's the second block, and this is the second byte in the block. We're looking at the third byte in the block. We're just going through one by one. So I just call it byte key because that makes more sense. And the same with the byte value. It's the on our current block, it's the value at our current key. That's the value. So I added this in too, because I was like, well, if we could be using different tables, and this is on a per individual byte, which is convenient because our switch bytes are going to be on a per byte basis, and it's going to change depending on what byte we run into. If we run into that switch byte, it needs to change, and then all the bytes after that are going to be encoded differently. So this is pretty simple. We've got these conditionals. So if not is set current table. So basically, if we haven't run this before, I probably could have just said if byte key is 0 or something too. Like, it doesn't really matter. But anyway, I decided to say if not is set current table, set current table to table. So that's pretty straightforward. Now, else if switch byte 2 is not null. Now, switch byte 2 is only going to be set if we have 2 switch bytes, and that's only going to be the case if we have 1 byte for switching to one encoding and a different byte for switching to a different encoding. And I think I've seen that in a game. So I said if, byte value, the current byte that we're on, its value is equal to the switch byte. So if we're on the switch byte, then they switch the current table to table 2. And otherwise, if the byte value equals switch byte 2, if we're on the second switch byte, then the current table equals the original table, switch back. Now, then we do another else if. So if switch byte 2 is not set, basically, if switch byte 1 is set, if that's not null, then we know that we're dealing with switch byte, but it's only 1, so that switch byte needs to act as a toggle. So again, it's just going to be if we've hit the switch byte, if the current table is table, then switch it to table 2. Otherwise, switch it to table. That's pretty straightforward too. Now, what I've decided to do with this is get the encoding of our diacritics. And I could move this, like these are just like the actual characters I've just copied but pasted in here. That I use for the diacritics. This is for like our 1010 and our Maro character, or our Doc 10 and Han Doc 10, I think, characters. And I should probably call them Doc 10 and Han Doc 10, because I call them that everywhere else. But for some reason, when I wrote this, I decided to call them the 1010 and the Maru. And I should probably change it. And anyway, what I was thinking is I could put these values into the config files and pass them in, because then if this wasn't the actual character that's being used for in the table file for the Doc 10 character, I could specify that per game. But I make all the table files, and I always use these characters, so it doesn't really matter. Anyway, this is how I did it. And so this, what I basically had here was this, and I've commented all this out, that this used to do all the lifting, and I even started putting in some stuff here that I haven't filled out. But as I was doing this, I'm like, this is confusing, and it was made to work with single bytes, and I'm doing all kinds of stuff with dual bytes, 2 bytes, double bytes. So I decided to change how I did it. And I honestly, I thought about this for a whole day, and I'm kind of embarrassed about this because I don't feel like this is really any better than it was before, but it's a little better. I don't like how big this is and how this is a huge list of conditionals. It feels to me like I should be able to pare this down by moving some stuff into functions or doing something better. But I'm not going to beat myself up over it. I guess there's some good thing. This works. That's one thing. It's important that your code works. So because this works, that's just good in and of itself. And I can also understand it, so that's good. So to aid in my ability to understand what I'm talking about here, I basically define the values that we're going to check. So if you think of this as we're going through each individual byte, okay? So we're on byte whatever, we're on byte 0 to start off with. And what I realized is basically the only bytes we're going to care about are the next 3 bytes, essentially. Because I want to know if we have a Doc 10 or Han Doc 10 character that comes before or after an unvoiced character. And either of those things could be single or double bytes. So what that effectively means is that we know what byte number 1 is, so to speak. If we're starting at 1, it's this byte value. All right, so that's our, let's say, our byte number 1. So our byte number 2 is going to be whatever is at our, it's going to be whatever is at our byte key plus 1. It's going to be the next value, and then our next byte after that is going to be whatever's at our byte key plus 2, and then whatever's at our byte key plus 3. So So I define these. So I call my individual bytes, and honestly, the only bytes I'm really gonna care. I'm never gonna care about like the fourth individual byte, because it's only ever gonna be like a 2-byte encoding and a 1-byte encoding, or a 1-byte encoding and then a 2-byte encoding, or like 2 1-byte encodings. The only time that fourth byte is ever going to matter is if it's 2 2-byte encodings, because then that ends up being 4 bytes. So anyway, so I define 3 single bytes. Our first single byte is already defined; it's byte value. Our next single byte is byte 2, and our last single byte is byte 3. Okay. And then I still define 3 double bytes also, because the first double byte is going to be basically the first two bytes of our 4 bytes. And then the second double byte is going to be the second single byte and the third single byte, and that's going to be what I'm going to want to know about if we have a single byte encoding before a double byte encoding. And then double byte 3 is going to be the final two bytes of our 4 bytes, because we could have a double byte encoding followed by double byte encoding. So that would be basically double byte 1 followed by double byte 3. So we do that. So then I basically split this up into 2 conditionals. The first is like if the diacrit type is pre. I guess it's 3. Then it's if the diacrit type is post, and then it's if no diacrit type is specified. That's just going to be our else. And then we have all this, which I think is really ugly and I don't like it, but it works and I think it's alright. So what we basically say is if there's a 2-byte doc10 followed by a 2-byte unvoiced character, do this stuff. And our conditional for that is if our double byte 1, that's going to be our first 2 bytes, equals the 1010 encoding, and we have to check if this is sex, otherwise it gives a notice saying that we tried to do something with an unset thing. The main thing we're doing is just doing so we're saying array key exists, so it's checking to see if this key exists in this array, and that's the doc10 array. So if we go back to our script dump here and go to doc10, so what we're doing is we're looking to see if in our current table file, if the value is in our encoding that we're working with is for one of these unvoiced characters. Okay, so it's actually going if current table and our double byte 3, which is our last double byte, so we're checking for the two double bytes, winds up being the encoding for this unvoiced character, like for instance Ka, then we if it exists at all in this table, we know it's something. It could be Ka, it could be key, it could be whatever. What we're going to do is we're going to say that that our current byte is going to be lookup in doc10, which is this. The current table, what is encoded in the current table as our last 2 bytes, and it's just going to pick whatever one of these things is encoded as that, and it's going to give us back the voiced character. That's what we want. So we're going to set that voiced character to our current byte. Basically we're encoding the text, so we're switching it from a byte value to this actual character in our encoding, and we're unsetting the rest of the stuff, and then we're skipping to our next value that we care about, because we've already accounted for basically for 4 bytes in this script, and we've encoded it into this one single voiced character. And we're going to do that for everything else. So I do this exact same thing again, but for the Han doc10. That's the only difference. So I feel like I could have made a function out of this where you basically just maybe you pass you know, whether it's Maru encoding or 1010 encoding or whatever, but it doesn't really make sense because, like, you have to do something different in these two, and then you have to do something different in these two, and you have to do something different in these two. It just made the most sense to write these all out. I don't know. Maybe somebody out there can think of a better way to do this, but I just had to write all these conditionals. So if there's 2-byte doc10 followed by 1 byte, if there's 1 byte followed by 2 byte, if there's 1 byte followed by 1 byte, and then what could happen, you know, of course, in a lot of this, is that our diacrit type is set to pre, but we're not dealing with a voiced character. We're just dealing with something that's in our encoding, and it just needs to be encoded, and that could be 2 bytes. So at first I check to see if there's a 2-byte match, and if there is, we just, you know, if none of these other conditions have proven true, but this current byte we're on and the next byte that we're on match something in our table file, then let's go ahead and swap that out. We'll encode it, and then if there isn't a 2-byte match but there's a 1-byte match, you know, the current byte that we're on matches a single byte in our text encoding, then go ahead and swap it for that. Now, so then we do the same thing for post, and all that does is it just switches it around. So, like, we need to be concerned with if the doc10 comes after the unvoiced characters. One thing that annoys me is it does mean that I have to account for just a single 2-byte match or a single 1-byte match if we are also in if we also have post set. But I could have gotten around that by, like, this just didn't seem all that bad. I basically I do this same thing here. I do it at the end of this, and I also do it here if neither of those things are set. This is basically the same code. I mean, maybe I could have turned this into a function, but again, it's conditionals. I don't know. This works, and I think it's fine. So that's what it does. Conceptually, I think it's pretty straightforward. I return the blocks. This is our block dumping function, and it's pretty straightforward. You check to see if the file exists. You make the file if it doesn't. And this is my merge thing. So, you know, if merging is on, all I do is I start an output buffer. So this is pretty easy if you know anything about output buffering in PHP. I basically just print the information into a buffer, and then I write the buffer to the output, and then I just write the output. You know, otherwise I don't. Like, the output just is, you know, it's just for each individual block becomes its own file. And that's it. So let's, I guess, well, it's not quite it. It's mostly it. So let's go ahead and take a look, I guess, at what we get when we dump this. So we're going to go to Magic Knight Rayearth script, and this is actually already, you know, here. I just redid all of this code, so I had to test even just that this is working for this, you know, Magic Knight Rayearth. But anyway, our script dump is set to mchar2, so it will dump the script and it'll put it here. So let's run it. We're just running it in a web browser. Bang, and we get script 0. This just happened at 10:40 at night here, and we're going to put it in, doesn't matter, one of these. Okay, and here it is. And this is what we're supposed to see. And I tried doing some formatting on this, so we get takarabako, so it's a treasure chest. Akete miru ne, so it's like, yeah, I'm gonna try opening it up. So yeah, so what I did is I went into the config. So we did all of this stuff because this is a pretty ugly script otherwise. It's easy because we've defined like a single byte that works like a break in the line break in the text. So I basically tell this in my post-processing function to say, okay, you know, make on the breaks, go ahead and break. It's here somewhere. I don't know. Oh, here we go, right here. So I just say, you know, multi-byte replace breaks with. So I didn't really need to do it this way. The reason I started getting into this notation was for this kind of stuff. So, you know, your breaks are simple. Your endings are normally simple, but if I just go through and have all these ends, like, break on these end characters, it uses the same byte it seems to be to indicate, like, an end of text, that it does to, like, it handles a lot of stuff. Like, I think it triggers a lot of the animation and the behavior in the game. So it's really annoying. Like, you pretty much have all of these ends that have, like, an extra byte on them, and they change. So I tried to start capturing them all. Like, I was going through here and I was like, okay, if there's an end followed by a single character and another end followed by another single character, break on that, because that was like these kind of things, and it seemed like there was a lot of instances like that where it made the most sense to sort of like that was kind of where some text ended and then some other text started. But you can see I still have stuff in here, like, you know, you've got some text and then you get these control codes. It's like this with one character, it's like a character that's in our encoding, a byte that's not in our encoding, another byte that's in our encoding, then we've got this, then we've got a couple other bytes, you know, and it's hard to capture everything. I just found that doing these general things, like, I just couldn't capture everything. So I was like, well, can I get more specific? So I started capturing, like, specific, like, I'm like, okay, so I'll do this, and this, break on that. You know, so you can see I started doing that with some of these things where it made sense. But I started getting, like, you know, over a dozen of these specific instances, and it wasn't helping. It's really hard to format this script. So, you know, again, this is just a limitation of the way that I dump these scripts. But I can translate. You can translate around a lot of this. You're just going to have to use your brain and translate around some of these control codes, and that's not so unusual in fan translating. But I wanted this to be super clean and nice. But the really great thing is that I was able to account for this mixed encoding, single and double byte encoding, and I was also able to account for switching text encodings based on switch bytes, which didn't end up coming in handy with Magic Knight Rayearth in particular, but is going to be handy for dumping some other scripts here. So I hope that was interesting. I know this is super long. It was probably super boring, but you know, I guess I don't care. You know, I'm posting these in case you find it interesting. So if you made it this far, I assume you did like it, and I appreciate you watching. I hope you'll join me again for more of these videos. Take care.